Hello, and welcome to a developing story. This video will present the development of 3D UTAPWeLS through the past years. It has evolved from single programs to toolboxes, and then into a fully integrated application with multiple modules. So much has changed and improved over these past 20 years. Not all can be included in this short video. Some years may not have many visible improvements. Much of the work was done under the hood, enabling better performance. Some of you may have witnessed the development over these years. Those who have not will get a better understanding of how 3D UTAPWeLS evolved. 3D UTAPWeLS began with the idea to create a software application that would simulate well logging situations. The path to the solution was to work toward the following objectives. Create algorithms for the numerical simulation of wireline logging, logging while drilling, and cased hole logging measurements, interpretation of measurements with in situ permanent sensors, quantitative integration of well log, 3D seismic, well test, and production data, simulation of multi-phase fluid flow phenomena in the near borehole region, inversion of near borehole measurements into physical properties and petrophysical variables, joint interpretation of single well and multi-well logging measurements, for the integration of 3D seismic and well log data, use laboratory measurements of fluids and porous rocks to estimate petrophysical properties, innovative data interpretation projects that integrate the use of well logs, geological information, 3D seismic data, and production measurements. This figure shows that objects were interlinked and used as a guide in the development of the software. In the early years, the software code was written. In association with MATLAB, the code ran a simulation to produce a log plot. The programs then became toolboxes with graphical user interfaces. At the 2005 Formation Consortium, the presentation reported on a program developed in-house, the Formation Evaluation Toolbox. Using Fortran and C++ software for borehole geophysical applications, it ran in MATLAB for a user-friendly interface. The objective was to develop and test novel methods for integrated interpretation of well logs, rock core measurements, and seismic amplitude data. These are representative of achieving that goal. Monte Carlo simulation of LWD neutron and density logs was presented in 2006. An LWD simulation tool was developed to understand nuclear responses in certain well configurations. This enhanced log interpretation and formation evaluation. The tool was designed, calibrated, and LWD was simulated for neutron and density. This log is an example of a test response of the new LWD nuclear tool. 4 software tools were presented in the 2007 consortium meeting. They are the Borehole Resistivity Toolbox for simulation and inversion of borehole resistivity logs, the Formation Evaluation Toolbox for simulation of water-based mud infiltrate and effect on borehole resistivity and sonic logs, the Borehole Sonic Toolbox for simulation and interpretation of sonic waveforms, and the Formation Testing Toolbox for simulation and interpretation of dual-packer formation testing. In 2008, the toolboxes were integrated into what was called the Petrophysics and Well Log Modeling Platform, with the acronym UTAPWeLS. Among the borehole resistivity module updates was a module for deviated wells with anisotropy. Also, improvement in modeling for LAS files, along with automatic determination of bed boundaries. Added to the formation evaluation module, improvements were an enhancement of the oil-based mud filtrate invasion module, improved interaction between the input model and simulations. The borehole sonic module advances included better compatibility with the borehole resistivity toolbox, improved STC and frequency dispersion algorithms. In the formation testing module, there was improvement in the input-output module, plus an updated transient pressure display module. Progress in the pore-level petrophysical toolbox included the ability to construct grain packs with variable grain size distributions, and now multiple options for compaction and cementation. In 2009, the application was renamed the University of Texas at Austin Well Logging Simulator, or UTAPWeLS. The software modules are now fully integrated around a single multi-layer model. Resistivity, nuclear, sonic, and formation tester measurements were simulated both before and after invasion. This was to cross-validate and verify the constructed static and dynamic multi-layer models against available measurements. The pore-level petrophysics toolbox was integrated into UTAPWeLS. This module created a grain size distribution pack, which could be voxelized for testing various parameters, such as percolation. Imported CT scan data was transformed into a TVOX image for similar testing. In 2010, in addition to the MATLAB-based version, a MATLAB independent version was now available. A license was also necessary to enable the software to be installed, and a new log calculator was available. In 2011, there were many visible updates to the application. Improvements in the fluid flow module shown here by the added icons. The nuclear simulator became faster for modeling nuclear logs, along with new nuclear features. To make working with the program easier, a right mouse click within the well track enabled the calculation of the nuclear properties to be run. There was also a menu item to be able to change a layer's hydrocarbon composition. There was a new Sonic Studio, an enhanced and improved petrophysical calculator. A plot template could be created from one well and used in another within the project. Development did not slow down in 2012. A D-list file reader was incorporated into the software. The Sonic Studio had a faster waveform processing for STC and dispersion, plus more control over how it was displayed. There were also improvements to the high angle and horizontal well display. There was a streamlined interaction between invasion simulation, resistivity, and nuclear logging simulations. Among the new developments for UTAPWeLS in 2013, for effective medium theory, there were new shapes added: needles, spheres, disks, and penny cracks. The palette for sonic modeling had additional capabilities. LWD and wireline resistivity tools were added, many developed in-house. The 1D sonic simulation is new. There was a more robust and versatile formation tester. In 2014, work on the NMR module produced an extended palette for NMR calculation preferences. The ability to change pore sizes was added. There were improvements in the NMR Studio for NMR modeling. Simulated LWD borehole nuclear images were able to be displayed in the tracks. New pore-level petrophysics algorithms were added to the module. CT images could be added to the pore-level module for interpretation of specific regions. In 2015, UTAPWeLS is now referred to as 3D UTAPWeLS, which is reflected in the new main window. In addition to global menus and tools, improvements were made to the navigation tree. A record of well project conditions at a specific moment could now be taken by snapshot at the user's discretion or automatically at prescribed intervals. This created the ability to recall a previous record from within the project. There were faster 2D sonic simulations. Depth shift of logs was added to match logs. Custom calculations are now available. Improved log display for highly deviated wells. In 2016, enhancements of the modules continue. Among them, the addition of rock classes, which enables the user to assign a different rock class to one or more petrophysical layers. The Thomas Steiberg diagram is interactive. Depending on which type of structure chosen, the vectors and areas of the diagram can represent potential changes within the rock formation. As seen here with two different structures, first with laminar structural, moving the mouse will change various petrophysical parameters, and then with laminar dispersed, each associated with a specific area within the diagram. The volumetric reference also became interactive, allowing on-the-fly changes. Depending upon which volume type is changed, a change in petrophysical properties are also modified. Ease of use improvements were always welcome. There now is the ability to switch to a specific layer within the palette became much easier. Also, using the custom settings, one can choose which layers can be changed. UTNuPro, a UT-developed bulk nuclear properties calculator, utilizes an expanded cross-section libraries to use the latest nuclear data files and a more complete element database. There were also user-requested enhancements. Simulated log sets are able to be renamed, which allows the testing of multiple hypotheses for the same tool. For MATLAB users, a new scriptable backend to enhance the workflow. Some of the additions or enhancements in 2017. Table view was added into the Earth Model Builder, enabling importing and exporting of data quickly and efficiently. The number of models for slowness calculation in the effective median theory module was increased. In Log Studio, the depth shift tool now has the ability to match logs by using multiple anchor points. The 3D spontaneous potential simulation tool was improved and became capable of using a 3D model. Induction-based tools were added into the inversion resistivity module. Another user request was to have a plugin for TechLog. The plugin was developed in-house, which allows data to be shared between 3D UTAPWeLS and TechLog. 2018 improvements in 3D UTAPWeLS included the NMR data and studio, along with a new interface. Now, forward T1, T2 distributions and inversion calculations are possible. In the Cross Plots module, multiple plots from different wells may be viewed simultaneously. In the Markov chain Monte Carlo module, inversion of other Earth model properties such as gamma ray and bulk density are now available. Every year improvements keep coming, and 2019 was not an exception. With mineral composition, spectral log mineral compositions are able to be imported into the Earth model to work with the data. The MCMC for inversion now takes bed boundaries into consideration. In the SP log simulator, the electrokinetic and electrochemical effects are taken into account. Another helpful tool is the undo and redo of Earth model modifications. The resistivity logging simulator had been re-engineered, and scripting has become more simplified and consistent. Over the years, there have been many contributors to the development of 3D UTAPWeLS, and it is all centered around the Formation Evaluation Director and Founder, Carlo. The consortium members, past and present, always need to be acknowledged. Without your backing and input, these developments would not have been possible. Thank you.